All to Professor Ajay Sood, Principal Scientific Advisor to Government of India, and our distinguished guests, esteemed speakers, and respected delegates. Welcome to this special session on artificial intelligence for social impact, organized under the aegis of the Ministry of Electronics and Information Technology, Government of India. MITI is committed to promote scalable, inclusive, and responsible AI. We strive to ensure that AI ecosystems in India respect privacy, inclusivity, and build trust while being tailored to our country's unique socio-economic context. Through the AI for Social Good thematic sessions, we aim to encourage deliberations and gather insights from leaders and experts in the field to catalyze the responsible and inclusive use of AI, driving measurable social impact and fostering equitable, sustainable development for all. To achieve the same, we have brought together a stellar range of speakers from industry, academia, and government who will provide valuable insights from their rich experience. We are privileged to have with us Sri S. Krishnan, Secretary MITI, as the session chair. I now invite Sri Krishnan sir to give the opening remarks and set the tone for today's discussion.
For the session will come and sit here, or they will continue to sit there? What is the format?
Sir, yes, you, after that, the keynote speakers will sit again back there. Only the panel discussion speakers will be here.
Come here. So I also go back?
Yes.
Okay,
yes.
good.
After that, Abhishek sir will facilitate it.
Okay. Thank you. Good afternoon to all of you. And today we have an important session as part of the first ever Emerging Science, Technology and Innovation Conclave, which was inaugurated yesterday. And to be honest, I was not in the country yesterday, I was flying back, but the impact that it made, even overseas, was tremendous in terms of everybody has been speaking about what the Prime Minister had to say, the new initiative of RDI which was launched, and the manner in which science and technology-driven growth and development in India is the new way forward. The expectation, the excitement was palpable practically anywhere that one goes. So truly, in a number of ways, the fact that we have this new format of the conclave where the emphasis is how technology can truly impact development, truly impact what is to happen with India is something which is truly critical, and we are at almost an inflection point in the application of technology. And in that sense, the Ministry of Electronics and Information Technology is one of the scientific ministries in the Government of India, is very proud to be associated with ESTIC. And we are also very grateful to both the Principal Scientific Advisor and the Secretary, Department on Science and Technology, for affording us this opportunity to actually host this session on artificial intelligence and the social impact that it has. And this particular session is also, in some ways, a lead-up session to another event which is to take place in about 3 months' time at the same venue, which is the AI Impact Summit 2026, which India is hosting and India will be chairing, where we are expecting more than 100 countries to take part, large number of companies, large number of stakeholders, academic institutions and others to be part of that event. And fundamentally, again, focusing on broadly very similar issues. The summit itself, as is titled, addresses the question of impact. It's the manner in which the entire narrative, the entire discourse around AI is shifting. In November 23, when the first of the international summits was held, it was called the AI Safety Summit. From there, we moved to Action Summit by the time we came to France earlier this year in February. Now we are moving on to impact, in the sense, what difference can AI make as a technology for the world at large, and especially for countries of the global south and a country like India. And that is, I think, one of the critical aspects. And the critical aspect ultimately of all technology is the impact that it has on society, what it offers to the people of the country as to how it can talk about enhancing quality of life, enhancing what exactly life can, how exactly life can be with enhancement of technology. And in many ways, for India, this is truly an opportunity. It reflects an opportunity to leverage a horizontal cross-cutting technology like AI to make sure that the country is firmly on the path to becoming a developed nation, a Viksit Bharat by 2047. We have just about 2 decades to achieve this, and it's only through technology that we can achieve that kind of development which would lift practically everybody in Indian society by in a matter of 20 odd years. So I think that is where the impact is going to be critical, and at the same time we need to protect ourselves. We need to ensure that any technology cuts both ways. Any technology is two-edged. So we have to ensure that we handle it in a way which is safe for the people, we handle it in a way that it is truly beneficial, and the negative effects of it are kept at bay. And clearly, if the positive effects are magnified and can be exponential, so can the negative effects. That is how technology again works. And therefore, we have to make sure that we harness the positive benefits of this, guard against whatever are the negative elements of it, and make sure that we are able to harness it for the effective purposes. There are many ways in which, as a country, thanks to the bold vision that the leadership has, we do not fear this as a technology. We approach it from a positive perspective. We approach it from a perspective of the way that it can impact life in India. We can approach it from the perspective of how it can actually improve outreach, how it can be significantly more inclusive, how we can actually truly govern in the language of the people. How through Bhashini, through a variety of other applications, we can actually make sure that everything that we communicate is simultaneously understood by all citizens of this nation. They can actually interact and get whatever services they require in a much more seamless, easy fashion, kind of service delivery which was unimaginable earlier. A kind of enhancement of productivity which we would have only dreamt of is something that we can finally have. And that is truly the way in which this can be harnessed and moved forward. So that would be the theme of today's discussion. And as a session chair, I'm extremely happy to welcome this galaxy of speakers who have been assembled for today's session. We are going to hear from a whole host of them, understand various dimensions of it, understand ways in which it has been effectively implemented at various levels. Also hear from visionaries who understand this at a much more macro level and would be able to contribute to our actually figuring out how exactly we can work with this technology in our way forward. There's also a very exciting panel discussion, and all of these, I think, would certainly be a treat. And when I walked in, I was a little surprised that we were hosting this particular conclave in the biggest hall that is in Bharat Mandapam as a plenary session. But even as I got to this auditorium, I've suddenly realized that it's almost filled up, and it is really the draw of the kind of panel that we've put together today and the kind of subject that we have before us that we can actually hear from very, very eminent speakers. And I look forward, along with you, to hearing from all of them. Thank you.
Thank you, sir, for your insightful opening address, highlighting the crucial role of responsible AI in nation building. May I now invite Shri Abhishek Singh Ji, CEO India AI, DG NIC and Additional Secretary MITI on the stage to felicitate Shri S. Krishnan Secretary MITI as a token of our appreciation. Now we have a dynamic series of talks from leaders who are shaping the future of AI innovation, from entrepreneurship and academia to global research. Each speaker will bring a unique lens to how AI is transforming lives and enabling sustainable growth. Our first talk is by Dr. Geeta Manjunath, founder, CEO and CTO, Nirma AI Health Analytics, Bengaluru. Dr. Geeta Manjunath is the founder and CEO of Nirma AI Health Analytics. She has over 25 years of experience in IT research and innovation and is known for developing Thermalytics, a novel AI-powered, non-invasive and radiation-free breast cancer screening solution. Her pioneering work combines data science, thermal imaging, and artificial intelligence to create accessible healthcare solutions for women, particularly in low-resource settings. I now invite Dr. Geeta Manjunath to share her journey and vision of harnessing AI for societal impact in healthcare.
No, I'm back. Good afternoon, everyone. After the very, very dynamic talk by Professor Ganesh, it's really a task to follow. As was introduced, I'm Geeta, founder CEO of Nirma Health Analytics. But actually, I was a scientist like many of you, from IISc, then HP Labs and Xerox Labs and so on. And when I actually, at very, very close quarters, saw how the diseases, particularly breast cancer, was affecting very, very close family members, I just said, what's the use of doing research for like multinational, solving European problems, Indian problems? Here is European problem, US problems, and here is an Indian problem that requires attention. And I just quit my job and started Nirma Health Analytics 8 years ago now. And I'm glad to say that now we're considered one of the pioneers of technology called Thermalytics, which is World Economic Forum called us as top 20 pioneers last year. And it is, of course, making a lot of impact. Thank you. Now, I was asked to talk about entrepreneurship. Before I talk a little bit about my learnings, I would say, about learnings or where we are today. I think we don't need any justification of why healthcare itself, solving a healthcare problem itself is a social impact, right? Obviously it's touching lives and so on and so forth. And yesterday as well, we talked a lot about the gaps that exist and the problems that we need to solve. So there is a huge scarcity of healthcare provisioning of equipment, skill set, and so on. Rising cost barriers, access barriers, all of it. Like there is a huge scarcity of need for solving these healthcare problems, be it equipment or solutions or whatever. That's definitely there. There's also new kind of demand that the patients are making. Even those who have access to healthcare, thanks to ChatGPT and others, they actually chat with GPT for 2 hours about their problem and come to a doctor and spend 2 minutes and expect the doctor to give the same answer or a bunch of treatment options that the GPT will have given. So they come with fully prepared list of things that the doctor should say. And so now the doctor needs some more tools to cater to this new demand that's coming. Having said that, thankfully to solve both of these types of issues, we have technological, evolution and new things that are coming. So how can we take this technological evolution that's happening, new aspects that are coming, and try to address both these types of needs that are coming in healthcare? This actually requires not just use of existing innovation, but it requires enhancements, advancements. So you have to go back and forth between science, engineering, and then commercial and so on. That is when we can actually take a real idea, that is idea to prototype, to actually market and make an impact really on the ground. When I looked at several startups that exist in healthcare domain today, typically we can group them into 4 major aspects, right? Device and diagnostics. Even with AI, we had software as a medical device. So far, whenever we talked about medical device, it was something like a device which you can touch and get healed or tested, some numbers will come. Now, with AI, we are talking about software as a medical device. The AI itself, the software itself is a medical device because it is analyzing a certain set of information and then generating a potential diagnosis, which, of course, a doctor can use. The bench of digital health and AI kind of innovations, this would be taking the existing data, analyzing the existing patient data from different methodologies, be it wearables, be it existing data in the hospitals, and then provisioning it in a way that the doctors can use better or the patients can use better. Telemedicine, all of these will come in this category. The third batch is generally how do we do pharmaceutical enhancements, right? Drug discovery, gene therapies, targeted drug delivery, right? How can we go find the cancer and then deliver the drug at that particular location? And several other innovations are happening here. And last is services innovation. How do we make this enabled at home, like home-based services, or generally, how do we make the patient life simpler, and so on and so forth. So all of these, as you can imagine, will be and is being enabled by AI. So there are several such things that can actually be solved with AI, as we have seen some examples earlier as well. Of course, AI can be used to reduce cost, patient experience, and all of this, and reduce misdiagnosis. It could be misdiagnosis as well as overdiagnosis that can be done. So when the doctor and the AI robot sits together, we can possibly have much improved outcome. But what is very close to our hearts, and this particular theme, is how AI can be used to bridge the divide that exists between haves and the have-nots, the developed and the developing countries, as well as the rural and urban infrastructure. In rural India today, one doctor is serving possibly 100 villages, right? It's really scarcity of resources, expert resources that exist today. We saw it in COVID, in wave 2, how there was really lack of resources, even ICUs, and we saw a lot of people losing their lives, right? Now, if you have an AI doctor, quote unquote, AI doctor, in a rural area, helping a healthcare worker identify the high-risk people at the right time and bring them to a nearest infrastructure where this can be done, that would be a major benefit. Likewise, in an urban infrastructure, especially the most busiest doctor is considered the most expert as well, right? They don't have, like, they are there till 12 midnight and they don't have time to have even coffee. Now, the AI doctor or AI specialist here can just help the doctor spend lesser time and make better decisions as well. So productivity. So there is a major potential and possibility of using AI to bridge the healthcare divide that exists in the world today, and definitely in India. While I'm talking all of this in a generic term, just coming closer home to what we have been doing for the last 8 to 9 years, we are actually looking at one particular disease and trying to see how research can bridge the healthcare divide that exists here. Breast cancer, it is one of the largest cancer killers in women today. 2,000 lives go every day because of this disease. And breast cancer is one of the most curable of all the cancers. Nobody needs to die of breast cancer, but still we lose so many women. And you see this diagram, pie chart there, 51% of cancer deaths happening in Asia annually. While we have 85% survival rate in US, India and other countries have 50% survival rate for 2 to 5 years. What this means is every lady or every alternate lady detected with breast cancer is dying within 2 to 3 years. So how do we save this? How do we enable this? By enabling early detection. People wait till there is a big lump before they even go to a hospital, right? So that's the awareness and so on. So of course there is awareness issue, affordability issue, access issue, on all of this. Can we bridge all of this? Can we solve all of this and make it actually happen is what the question we had in mind. And we developed Thermalytics, which is a new test for detecting breast cancer, which is primarily AI enabled. With this, we have been able to detect 4 millimeter lesions, which is considered stage 0. Hand can detect 25 millimeters. 4 millimeter lesions, that's something we are able to detect. That is much before a lump is felled. Today's technology works only after the lady becomes 45 years, and so we are able to detect it for women of all age groups, 17-year-old or even a 92-year-old. There is no radiation. Okay, what are we doing? We just measure the temperature variations on the chest using a thermal sensor, which looks like any of these cameras that are around here. Place it in front of the person, measure this as a click, 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 that's it, without touch and without radiation. We are all emanating radiation to the whole world because we are all heat sources. So that is what we measure. And by measuring 400,000, that is 4 lakh temperature points, we are able to convert that into a breast health report using a bunch of AI algorithms. It's a portable device and access is not an issue. What is also very interesting, because we wanted to keep it like a private experience for the ladies, so more women come and adopt this solution, we made it like a no touch, no see. It is, the lady is sitting in front of the device and even the technician is outside. She comes in, closes all doors and curtains and removes her clothes, but she's actually sitting in front of the device. No one is seeing her. The key enabler, as I mentioned, is AI, because the use of thermal sensing for breast screening is not our idea. It's been around. Medical people or medical science knew about it, even 30 years ago possibly. But still, it was not available everywhere because of the accuracy issue. Because the center image, what you see is like a heat map where this 4 lakh temperature points, light red, it's not really visible or interpretable using bare eyes, be it for human, simply whether it's a doctor or anyone else. So when we add AI to it, not on the image, not just on the image, but also on the temperature values, we're able to extract new type of patterns that exist there, which are indicative of potential breast abnormalities. And so a complete report is generated automatically, which the doctor can review. As well as in the rural area, we have a immediate triaging report that is coming in. By the time she comes out, her red, yellow, green is ready for the healthcare worker to decide whether she needs to go to the next level. Of course, this has to be protected. Many of you are startup founders here. Definitely, like yesterday also, many people on the panel were mentioning, protecting the IP is important. So definitely, we ensure that it's Make in India and reserved as Make in India product. The key innovation has been AI-based biomarkers, which is basically, of course, we talk about biomarkers mostly from blood, tissue, etc. But there's a new kind of set of omics, radiomics that are coming in as biomarkers. These are extracted from X-rays, MRIs, CT. We said, why can't we actually extract biomarkers from these thermal scans? So we ended up getting 117 different biomarkers from thermal patterns, thermal radiomics we say, and also vascular radiomics. And a bunch of 25 different algorithms and multi-expert, multiple aspects that were mentioned, were used here, not at generative models, because we still want to make sure that the output is predictable. We definitely have to make it explainable, otherwise the doctors don't understand what we are saying, and so obviously the trust in the solution goes away, etc., etc. Of course, it has to be clinically validated with prospective blinded studies, and publications in very, very top journals are important. Regulatory clearances are important, with basically it's also US and India cleared. And most importantly, we're able to reach the corners of India and then try to provide this solution. The main solution behind has been AI. Of course, so far only 3.5 lakh women have benefited, and now this solution is available in 22 countries. While I end my talk, I just want to it's a wonderful galaxy of scientists. So I think this is an opportunity where we have been able to create new biomarkers, just AI-based biomarkers. And of course, whatever we have seen is just tip of the iceberg. It's just breast cancer. But actually, this kind of thought process can be used to solve several other type of abnormalities, be it head and neck cancer, skin cancer, we have tried a bit, diabetic foot, etc. And so I call upon any of you who are interested in this area of work to make this as one of the prominent, possibly social impact methodologies or technologies for non-invasive preventive screening for multiple diseases. Thank you very much. No Q&A.
Thank you, Dr. Geeta. Now, the next will be the keynote address to be delivered by one of India's most visionary technologists and entrepreneurs, Dr. Sridhar Vembu, co-founder and chief scientist, Zoho Corporation, Chennai. Dr. Sridhar Vembu is the visionary founder and chief scientist of Zoho Corporation, one of India's most successful software-as-a-service companies with a global footprint. Dr. Vembu is celebrated for his unconventional and self-reliant approach to building technology enterprises. Rejecting the typical Silicon Valley model, he chose to base Zoho's R&D operations in rural India, empowering local youth through employment and education. Dr. Vembu has been recognized with several honors, including the Padma Shri for his contribution to technology and rural development. Dr. Vembu, may I invite you to the stage to deliver your keynote address, please.
Thank you.
Would you read us? Yeah, thank you, sir. Yeah. So, good afternoon, everyone. Vanakkam, namaste. I really apologize for coming in so late. I was in a meeting till about 11:30 in Chennai. I'm rushing straight from there, in the airport here. So, I actually just put in a slide in the last minute. I don't know if it got in. The very first one was going to be, yeah, it's not there. I will say it just today. I saw two pieces of news. One of them is there in the next slide. The first one, it didn't get in. It was there. It's there in my phone, but it didn't get in here. Is NVIDIA's latest chips will not be offered to most nations, including us. And what is interesting about it is, a lot of the IP is designed in Bangalore. So, there used to be a quote by Lenin, the capitalists will supply the rope to hang themselves. Unfortunately, in this situation, IP, we are supplying a lot of the IP that this is the reality in our industry today. Okay, we have to really truly understand what it means. So before, why I'm saying it is, we are celebrating GCC in a big way, but none of the IP is in India. None of it. And we pay dearly for it. Dearly for it. And sometimes it's not even available at any price. At any price. So we have to understand the implications. This stuff, I'm not talking about what Indians designed abroad. I'm talking about very much stuff that's designed in India, in our own shores. So, and that is what I want to point out. Because a lot of these companies, in fact, I've met people in Bangalore, in Hyderabad, who are working on very critical stuff in these GCCs. And some of the critical stuff is not actually accessible to Indian companies later, or Indian government for that matter. So that's something, or Indian defense, any of that. So that's something that we have to understand. Okay, it's a new development. I want to highlight it first because when you talk about AI, this is very important. And this is why one of the things, I'm very proud to say, from early days, we were very worried about this question. So we have ensured that everything we do is actually made in India and India registered IP. So something very important for us. And now this is actually work we have done with Professor Ganesh's team. I am not personally involved in this work. Our group in Kottarakara in Kerala is involved, Jairaj Porur. And we have found some very interesting things where Bharatjan Zoho collaboration, where how the word grouping in Indian languages, when we do this, for our specific, our language families, it works much better. You can see the slide there and you can see it, and Professor Ganesh would have already talked about it, so I don't want to repeat everything, but it's something that I want to highlight. My topic today is actually somewhat different. Even if all of the NVIDIA, all the technology were available to us, and right now they are talking about $1 trillion investment for going in easily, maybe 2 trillion. I think I'm underestimating it, but and already maybe 300, 400 billion has gone into this. These are mind-boggling amounts. There is no way that we can even afford a tenth of it. Okay, leave alone. There's no corporate in India. There is a mix of anything, and also even when the government is involved. I mean, should we put in 50 billion on AI versus some other pressing priorities? So it's not an easy question. So, which means that we have to find a different pathway here. As a technologist, I've been working closely in this. I do believe there are better pathways. There are other pathways available. In fact, when you don't have the resources, often those constraints come up, you come up with better solutions actually. And this is where I am actually going to post the point out. Yeah, this is of course the power, this other one. And repeat, this is also actually this morning I saw this. Significantly boosting electricity demand, and in the US in a lot of places it's becoming a political issue. Political elections in many states are now, this issue has come up. Electricity prices that are surging, often 50%, 100% increase in tariffs for residential customers to feed the data centers there. And the data centers are buying up bulk electricity from the power stations, which means the tariffs for the residential customers are going up. So this is a political issue there. And so even from that point of view, we cannot afford it right now. In other words, this is where I want to set these things here, because what is our realistic option? We have to be very clear. What are we going to do about this? Because this is the kind of power. And we have, in fact, as a technologist, I will also say, if we are going to build all those power stations, there are many more pressing national demands than just AI for us, right? For the power. So, and this is, how much power. And AI data centers alone consumed 4.4% of all the electricity. And and that's 7.2 million American homes, which might be actually 72 million Indian homes, okay, when you translate that into actual electricity used. So 165 to 365 terawatt hour. So to 12% of US power. So this is why I think these are all, all these are, I'm just putting up some numbers for the scale of all this, what the scale is today. So, and so there is actually more of these there. I have taken a lot of information on this AI, because once we have to first understand the problem, the magnitude of it. It is real, it is serious, and there is no easy solution. And the GPU availability problem is an independent problem. So first, they won't give us the latest GPUs. And if you get the latest GPUs, we cannot build the data centers with all the power we need. So there's like two-step problem here. Both are like gating problems, right? And so this already I talked about. So I will skip all this actually. I want to go to a particular slide here first. And I'll show you the quote. Actually, I think Professor Ganesh, you didn't put that up, my latest draft I sent you about 3 hours ago. Sorry, I've been working on and off. Draft 1, draft 2 I've sent him. But anyway, so what this is actually, there is a tweet from one of the big AI influencers or AI specialists. And he said when AGI arrives, we are going to be surprised that we could have always done this 25 years ago. That we missed something so simple, okay? And he said, and he actually put it in a very good mathematical way, he said, The solution to this is not going to come by doing the same thing more and more. It is, as mathematically put it, it's finding a new basis on which the solution is very simple. It's like how, in mathematics you have either the Cartesian coordinates or polar coordinates, all that. When you find a new coordinate system, your solution becomes easy on that system. He said it's going to be like that. AGA is going to be a problem of really finding the coordinate system rather than just simply repeating whatever we are doing in the current coordinate system that we are familiar with, that whatever the current AI systems are using. And this is actually very important quote, and I actually wanted to put that up. That's why that was going to be, that is my third or fourth slide there, but didn't get in here. But what this is something I have a personal deep conviction about. I have been pursuing the same line of reasoning. And while we are using all the open weight models, we are using our own trained models, all of that, those are all distillations or maybe very fine-tuned or smaller models focused for specific areas. So a lot less compute intensive, energy intensive, all of that. And we have gotten a lot of payoff from that. That's a low-hanging fruit that we can do quite well. Okay. So we, for example, have 7 billion parameter models. We are now doing a 70 billion our own model. Those are specific problems, business problems we are addressing with it. And we are already there rolling it out in our systems, and features are rolling out practically every week now. Those are easy, okay? But that's not any new science fundamentally. That's basically technology refinement, okay? But on a parallel track, I've been pursuing, maybe sometimes I feel so, hopeless quest, but I actually do believe there's some fundamentally new science possible here. And this is where that I referenced that quote which said that it's going to be like finding a new basis on which the solution is simpler. So, and in my line of work, so I am focused on a very narrow problem actually. Sometimes you have to very focus on a very narrow problem to understand it fully, then before you go to a bigger problem. The narrow problem is software code generation. And I've been obsessed about this for, maybe 10 years before AI, 5 years, 10 years, 12 years, because we deal in code. In fact, about 3-4 years ago, I wrote a post in our own company. I said, so far software engineers are like our handloom weavers. It's very much a cottage industry. We hand weave together code. Okay. It's not actually a very, for all the glamour software gets, it's very much a cottage industry of handloom weavers. That's how it is actually. Okay. You might be in front of a fancy computer, all that, but you're really hand weaving code together. Okay. And all the tooling has gotten better, but still fundamentally that process has not changed. And now is there a machine loom for it? Okay, is there a machine loom version of this for the handloom weaver? Something that is dramatic, 10x, 100x, okay? And when the LLMs came and they are generating code, it started to show that possibility, right? With a large language model, with all of the coding agents, all of that you have now, the 10x, 100x productivity possible. But right now, and that they called it vibe coding, right? And today, if you ask most people, they'll say the thing has cooled off quite a bit in the last 2 months or 3 months. The problem is it can give you a lot of code, but you are responsible for bugs, security, compliance, all of the nitty-gritty stuff. You go right back to handloom problem now. In other words, it can give you a lot of code, but you are responsible for it. So this also I have known for a while, that when LLMs give you all that code, superficially, the first version looks, you can run it, it looks good, but you go deeper into it, you'll find problems, and once you go attempt to fix those problems, most of the productivity goes away. And there was actually a very good study on this. On GitHub, they recruited 10 of the top GitHub contributors, people who are well versed in code, 10 or 20 people volunteered for this assignment. They did a kind of a real-time test of them using LLMs for their code, all the agents, everything, all the best technology available, and they measured their own reported productivity and the real productivity. And interestingly, the real productivity is actually either zero or mildly negative. The reported productivity is they thought they got done things faster. So they give you actually this illusion that you are getting things done faster, but there is a lot of code that is already there, but the attempting to make it into usable something is where a lot of the productivity goes to die. This phenomenon is well known in software development, where you are fundamentally, you can initially you get the prototype fast, and then actually launching a finished product, it seems to take forever and ever. That's where the productivity goes. And this is same with LLM. So, and because it's fundamental to our business, right? This question is very fundamental. Is there a machine loom? Our entire software industry's economics depends on this question. If there is a machine loom, the industry economics will look very different. The LLMs look like it. They may still get there, but they have not yet gotten there. That's why we are not losing software jobs at any large scale. And if there is truly a machine loom, the weaving problem will arise, because if LLMs AI can do all of that, you would require a lot fewer programmers. People will say, well, we can do 10 times the software, but actually, as it happened with clothes, right? All of us are, closets stuffed with clothes, but, there are no weaving jobs. So you have to remember that. It doesn't mean, just because there is software everywhere, there necessarily have to be software jobs. This is something I always remind our programmers, that there could be software everywhere, but that doesn't mean we'll get to keep our jobs. Keep that in mind. Those two are not the same thing. So this question is fundamental, and I have been pursuing this systematically for many years. And last few years I've made actually substantial progress. This is completely orthogonal to LLMs, and Professor Ganesh have shown some of the work, and some of the stuff we have running actually are even surprising to me, what we could do with all this. And we are seeing something like the 3x, 5x, 10x we are seeing now in our labs right now. I mean, it's not yet in production technology, but on a fundamentally different basis. So this is the kind of a different basis function I'm talking about, where these look more like your graph search kind of problems. Not, in other words, the LLM is really converting everything into a physics problem, a continuous math problem. But computer science is actually fundamentally discrete math, graphs, combinatorics, all of that, right? And there is, so far we are thinking that LLM, that's the only way to pursue this is through the continuous math. Or you quantize it, floating point in FP8 or FP4 or whatever, right? That's the current approach. And you make it more efficient by squeezing the bits there, here and there, harvesting it. Fundamentally, it's a continuous math problem, but you are extracting efficiencies by quantizing it, this and that. But what if there is a discrete version of it, right? I mean, to offer you an analogy, our DNA appears to be a discrete structure, that there is our genes, all that, genetic code, it's code. It's not a continuous math. There is actually a sequence, and they can even publish the sequence. That's a finite sequence of really those symbols. So, which means that there is a, structurally you can pose it as a different problem. And interestingly, graph problems also are matrix. And those matrix also you can use GPUs. Ultimately you come to GPUs, but they will be orders of magnitude more efficient. You require orders of magnitude less compute to get something done. These look like path search problems or constraint problems, all of that. So essentially what we are trying to solve is, can you construct code through like you play a chess game move. That's how I'm looking at the problem. Can you construct code just like how the best engines construct chess moves or Go moves, okay? And there is Monte Carlo tree search, all of those. But obviously the move it comes up with is legal. It may not be very good, but it's legal, right? Of course, now it is very, very good, so also. And in a similar way, can it come up with code that is very, very good for a problem? And there I found something very interesting. Almost all of what programmers do, I call it 99% versus 1%, is, I've come to the conclusion, is not really deep programming at all. It's only what I call mapping. Sophisticated, I used to call it sophisticated form of bookkeeping. You're mapping things here, you are, for example, taking a piece of data, converting it to another format and sticking it in a database, sending it to a browser and displaying a UI on it. Actually, none of this need to be difficult at all. And that's where I think maximal productivity can be extracted. That's where the 10-fold, 100-fold, all that can be extracted. Then there's the one problem, 1% that's really difficult, where it actually would not matter that much that you gain that. So you leave it as it is, even if it is left as it is. The very low-hanging fruit is the 99%. And that's what we are actually doing a lot of now. We have found that, and what is surprising is how deep this goes. I took some what fundamentally look like difficult problems, like compiler design, which is one of the more difficult problems. I found that maybe 97% of that is only mapping, not programming. So it's not 99%. If you look at a business problem, it will be 99% mapping. It's not my own terms, mapping versus programming, all that. So now why I'm saying it is this code generation. Now I'll come to the narrow domain. Actually, code generation is how AI is going to become intelligent. When it can construct its own tools, and those tools can, because really what is human, what specializes the human? We build our own tools. If AI can build tools, then, and reliable tools that have a specification and obey those specifications, like our planes fly, they are designed to fly and they have reliability, all those criteria they pass. So today's LLM code generation problem is it doesn't obey any particular specification in any reliable way, 100% reliable way. That's the problem. But once we can solve that, so the way I liken it is, you are growing code like some kind of a crystal growth, very systematically. And with the understanding that most of what you are growing is not really the deep programming, but the mapping. If we could do this, then I believe that's where I think that this is one pathway we are exploring right now. And this, I believe, is fundamentally more energy efficient. This is a way where you can grow tools, and so the intelligence is coming from the ability to make tools, not really only simply using existing tools. Today, by the way, a lot of the agentic stuff is tool use, they call. You're using the tools that are already built, not fundamentally growing new tools or designing new tools, coming up with new tools. So that's the class of problems that we are tackling, but this is a parallel research effort. This is not anything in our mainstream product line yet. It's not ready for any of that yet. But that's where I talked to Professor Ganesh a lot when he visited 3 months ago, and we have made even more progress in the last few months. And so I actually believe that could be a pathway that could show if we can invent tool building tools, tool building AI, I'm going to call it. That would be fundamentally more efficient. And obviously, there is an analogy here. Humans are building tools and we are not consuming, so many terawatts of power, right, to do this. So, and our own tools we build are a lot less, lot more. No, we are doing it with a much more energy efficient way. So there has to be a path. That's what I think. And there I'm sorry, I narrowly focused on the programming problem. Within that, I focus on the biggest subset, which is what I call in other words, can you split programming into these, and can you make the easy part trivial? That's the idea. Can you make the easy part trivial? Leave the difficult part as is. Don't touch it much. That is anyway would have been hand coded by programmers, but that part is very tiny. That those come as libraries anyway. So this is the broad approach, and this is the path we are taking towards a much more energy efficient AI. And the reason why it's vital is, well, I outlined two. We are not going to get all those GPUs, and we will need some years before we can design those chips. Even if we start the design now, it will be 3, 4, 5, 6, 7, 8 years before we get very usable technology. And then we have to fab them somewhere. Those fabs could be not available to us. So we have to build those. We are building fabs, but those fabs will have to get faster. You see all the daunting challenges. And then finally, if we succeed at all that, then where is the power? Right? Which is why I have been on this path. That's the second path I said. But this also goes back to my own fundamental question about, are there machine looms? Question. Are there machine looms? So now I actually believe there are machine looms. I do believe it. And which is why, actually for a good reason, we are not hiring very many programmers now. We are only hiring customer-facing people. Because I believe these tools will get more powerful. Not the current LLM, by the way. That's not what I mean here. But this better class of tools. These should be fundamentally more energy efficient. In fact, some of these tools can be squeezed down to run on your phone, on your browser. On your browser. That's what orders of magnitude less compute means, right? If you are using 1,000 times, 10,000 times less compute, well, you can squeeze it into your phone or your browser. So that's basically what I'm after. And about 70% of my time is spent on it. 30% is spent on all the rest. So that's why I've been very, very passionately pursuing this project for many, many years now. But I'm happy to say that the results look good right now. So I'll have maybe show something in the next few months in public, but that's where we are. So, and the connection to energy efficiency is that tool building tools. Can you make tools build tools, grow tools? And I think that can be done. So that's all really I have, and I want to thank you for listening. I hope it made sense to you, all of this stuff. And I'm happy to take some questions here. Yeah, thank you.
Thank you.
Thank you.
Mike, sir.
Yeah. Got some questions, maybe? Later on, okay. Yeah, thank you.
Thank you, sir. Thank you. Thank you, Dr. Rambu. Our next speaker for the day is Dr. Shriram Raghavan. Dr. Shriram Raghavan serves as Vice President at IBM Research, leading global efforts in artificial intelligence and its responsible deployment across industries. He is recognized for pioneering innovations that combine AI with large-scale enterprise systems to solve real-world problems in finance, healthcare, and public policy. His leadership has positioned IBM Research at the forefront of AI governance and technological transformation. He is passionate about the responsible use of AI and advocates global collaboration in shaping equitable AI ecosystems. Through his talk, Dr. Shriram Raghavan will be sharing his vision of scaling AI for India with open innovation. Dr. Shriram Raghavan, may I invite you to share your vision, please?
Good afternoon. It's an honor and a privilege to be part of the first edition of STIC 2025. So thank you to the organizers for the opportunity to share a few thoughts. I want to use the next 10 minutes to really talk about three things. One is the importance of what's happening with open innovation ecosystems in AI. Open innovation, open software is not new, but certainly I think it has taken a leap in terms of what's happening in the field of AI. I want to share a few examples of what we are doing in IBM and IBM Research in terms of both supporting, nurturing, and contributing to open innovation. And then I wanted to really end with a call to action that the use of open innovation is certainly central, I believe, to the scaling AI and for solving problems at the scale that India needs problems to be solved. Just a little bit of reflection. Every era of software technology, we have seen open technologies. They have not just been examples, but they have tended to define the narrative in each of those. Whether you start with the beginnings of the Free Software Foundation, to operating systems, to web infrastructure, to development tools, to data processing, every era, major era of software, we have seen open technologies become the foundation of even commercial software. We certainly believe that's the case with Gen AI, and it has happened even more rapidly than in some of these previous eras. And what you see here are examples of open source projects that really are all industry-defining open source projects. Just to put a little bit of numbers behind it, these two are charts from the AI status index, I believe that's what it's called, that Stanford releases every year. It's a global survey. They released it earlier this year. Two charts are noteworthy. In a matter of a few years, there are over 4.3 million AI-related projects in the open. And if you look at the share of open source projects, it's very interesting to observe that the rest of the world is actually growing faster. The US is dropping, and India actually has a 19% share and growing of open source AI projects. That's illustrative of the opportunity for open innovation. The second part of AI is obviously the models. The first part is the tools that you use to work with AI. The second part is models. And it's also becoming clear that open weight models have dramatically improved in their quality and efficacy. And while they may not have every feature of a frontier proprietary model, they can be way more efficient and potentially more manipulatable as you start to build solutions. So progress in open weight models, progress in open technologies for AI are both, I think, happening at a rapid pace. And at IBM, we've been a long-term commitment to open source. We are part of this journey now for not just 25, I think over 35 years. Several foundations that have been involved in open source software, Apache, Linux, Eclipse Foundation, more recently PyTorch Foundation. And we continue to invest, grow, and nurture open communities. We fundamentally believe that that is a scalable way to build software, and that then that can be harvested, obviously, for commercial offerings. And just to give an example of how we think about it from an AI context, this is obviously our history over several years. We have chosen to invest in a set of 20 plus open source projects, and I'm not going to go into each one of them. These are all symbols. If you are in the technology field, you will recognize these icons. We have chosen to invest in about 20 plus open source projects at every layer of the stack. Every layer of an AI stack, from the platform that you use to run and serve models, the platforms that you use to do data processing, obviously supporting models, and I'll talk a little bit about our own models, the middleware that you use to build agent applications, etc. We have doubled down on leveraging open source, and which means we both contribute to open source and nurture open source communities. And this is a really, really rich and important space, often underestimated in its potential to be a crucible for innovation in AI. So just to illustrate an example of like 3 examples of projects that we have doubled down on. There is a project called Docling, which in less than a year has become one of the most popular projects for document processing. The document processing is central to so many Gen AI applications. You have to do it efficiently, fast, you have to do it in a lot of languages, deal with a lot of formats. This is a pain for developers. There is no reason for every company, every developer, every solution builder doing AI solutions for India to have to reinvent the wheel if there was an open source project that actually did a really, really good job of that. And Docling is something we have seen dramatic worldwide adoption. So this is something we also commercially embed in our offerings, but is also available as an open source project. And over the course of the 9 months, it has actually become a #1 repository of the year multiple times over the course across all worldwide projects in GitHub. So that's one example. It has 40,000 stars, a rich and robust community. That's an example of an open source project that could be the basis for adaptation and specialization in an Indian context, making it available to a large spectrum of solution builders. Another example of something we have put out in the open from IBM is our models for time series processing. Time series data shows up in every domain, from retail to finance to almost anything that you can think of. And again, these are really small, compact models consistent with the narrative you heard today. Those models today even run on CPUs, to the point that sometimes you don't need GPUs to do AI. They are 100x smaller than a lot of other models. And again, we have seen dramatic adoption. We've seen 25 million plus downloads of these time series models. And then we continue to invest, of course, in open technologies. LLMD is another open source technology that is used for efficient serving of open models. Now, without going into the technology, the reason I'm talking so much about open and IBM's investments is building platforms and technology with open interoperable interfaces makes for agile innovation. And this is why we are very, very happy that we have had an opportunity to collaborate with BharatGen actually in starting to put together what we call AI solution kits. There is this template where you can take trusted sources, build agentic applications to serve the needs of different use cases. This could be agri data for farmers, citizen data for citizen services, legal data for legal professionals. And one of the ways in which we're looking to collaborate is to couple open innovation with BharatGen's models. And this allows you now to put together solutions rapidly because we are mixing and matching, obviously, lots of open technologies that enables rapid solution development. It allows you to give quality out of the box. And because this is open technology, you're not tied to any specific infrastructure, not tied to any specific cloud. You're not even tied to, to hardware to the extent that there is diversity in hardware. And as one of the examples, we've started working, of course, to do work in Agri with the BharatGen team. We just demonstrated a couple of months earlier an example of a solution that brings together a set of open source efforts that allow you to do from IBM coupled with models that BharatGen has. The translation model, the speech model, the agent interaction model, seamlessly layered on top of a platform that lets you develop, manage, govern solutions. And we think that this is a very, very effective and powerful way to rapidly roll out solutions because you are not solving the same problem of data processing, data management, governance over and over again. You're providing a scalable platform to be able to do this at scale. And with open source technologies, you're not tied to individual providers, you're not tied to individual infrastructure, and you have the opportunity to scale the solution rapidly. Now, I think the other lens of scale, one is openness and transparency. The other lens for scale is efficiency. And I think, Dr. Sridhar talked to us about the importance of building efficient solution, both from the lens of power and from the lens of GPUs. So one of our focuses as IBM has also been that a focus on really compact and efficient small models. We've been developing and releasing. All of these models are released in the open, again, with Apache 2 licenses, which means there is no encumbrance on how these models can be used. I'm not going to spend time on all of these models, but to give you a flavor that they cover a wide spectrum of use cases, from language to time series to vision to speech models. And to illustrate how rapidly the technology is evolving, I wanted to share with you some statistics about the latest set of models that we released. These are our Granite 4 set of models. Without going into the technology, I wanted to call your attention to the leftmost corner of the page, which talks about how much these models can be shrunk in terms of their ability to run on smaller and smaller hardware. We in fact have now teams starting to be able to run these models very effectively inside of a browser, on CPUs in some cases. And because they are open, they are adaptable to lots of use cases. And Dr. Ganeshan has talked about the emergence of state space models. Actually, these models combine transformer and state space models to drive a lot of their efficiency. And this is actually a chart from a company called Artificial Analysis. They are a third party that they benchmark models. What they are plotting on the x-axis is memory requirements. You can translate that as how much hardware do you need to run the models effectively. The y-axis is, think of it as average accuracy for important tasks. And you really want to be in the top left quadrant because that means you can get a lot of work done with not a lot of hardware footprint. And you sort of see how much you are able to do at smaller footprints. And we're also proud, and I think this is certainly important, that we are actually the first open source model to be ISO 42001 certified, which means our level of transparency in terms of how we build the models, the process we use, the data sets we use, has met the threshold of certification of ISO 42001. And I also wanted to share that when we benchmarked, even for Indian benchmarks, which the team started to do, we've been using some of the benchmarks like Basha bench that was developed again here in India by the BharatGen team, some of the benchmarks like Milu. Again, we're able to see that we're getting excellent performance compared to several other models. This could be a basis for developing a lot of solutions. And again, it reduces energy consumption and it allows you to now roll out solutions more rapidly. So the 2 points I wanted to land are open innovation based on open source technologies and open weight models, coupled with a focus on efficiency, allows you now, I think, to scale quite dramatically. And these use cases for AI don't just go only on language models or models for code. We have certainly seen huge applications in other domains as well. And I think this is again a scenario where the opportunity to build models, open models leveraging open data, can widen the aperture of what can be built in this world. So over the last several years, we've been again working with open data sets. The collaborations leveraged NASA and the European Space Agency. But again, illustrative here is how effectively one can build models for Earth observation, for weather and climate models. We built a family of and released in the open models called Prithvi that was built jointly with NASA and ESA. We then built a model for ocean analysis that was derived from that. We've been working with NASA on solar physics models for Surya. These are all available in the open. And this is an example of the opportunity to build powerful reusable models built on open data. And again, in the spirit of bringing that open technology to help with Indian use cases, we started to do some work, early stages, with both the Ministry of Agriculture and the National Remote Sensing Center to understand how these models, infused with trusted Indian data, can start to address a lot of use cases, from land management to agricultural to disaster management to forestry management use cases. So again, another example where open models built with open data sets, wherever they are, can provide a basis for rapid innovation and customization on top to address specific needs in an Indian context. So I know there was a rapid view, but I did want to sort of end my summary with a call to action that the pace of innovation in AI, especially when you look at the amount of human capital being invested. We talk a lot about data center and GPU capital, but there is an enormous amount of human capital across the board being invested in AI. Really, really smart people, trained people across the world building very, very powerful technologies. Now, to the extent that we're able to harness that open innovation, both from a software perspective and a model perspective, I think it has immense potential. It has the potential to support development by scaling, by not having every solution builder continue to solve the same problem over and over again. Because these are open, they do not encumber you in terms of a dependence on specific providers, specific commercial operators. And I do think open technologies can tap into the amazing talent we have in the country and the opportunity for them to use these technologies to build innovative solutions. And I think open technologies are also more amenable to rapid customization and adaptation. So they certainly do not solve fundamentally the hardware access issue, but certainly they do, I believe, the use of open technologies allow you to scale more rapidly by building on the shoulders of work of smart people all across the board. We have seen that power in how software has been built more broadly, and I certainly see that same theme holding true for AI and Gen AI. So with that, I want to thank the opportunity to be part of this.
Thank you, Dr. Raghavan. Our next speaker, Professor Amit Seth, is a pioneering academic voice in semantic AI and social informatics. Professor Amit Seth is an internationally renowned computer scientist and AI researcher, serving as the NCR Chair and founding director of the Artificial Intelligence Institute at the University of South Carolina. His research focuses on knowledge graphs, machine learning, and human-centered AI applications. Over his distinguished career, Professor Seth has authored more than 450 publications and is one of the most cited researchers in computer science. A serial entrepreneur, he has founded multiple technology startups, bringing academic innovation and industrial impact. His contributions have been foundational in shaping modern AI systems. Professor Seth will be speaking on Beyond LLMs, the future of enterprise AI is C3AN. Professor Amit Seth, may I invite you to deliver your talk, please?
Thank you very much for this opportunity, this honor. Thanks, Abhay, for inviting me. As I start this presentation, I'm reminded of my day here in India on 27 December 2023. I had an opportunity to spend a good bit of time with Prime Minister Modi ji, and then he asked me to give a keynote at the third Chief Secretaries Conference. So our nation's top administrators, bureaucrats were all there. And in fact, Secretary Krishnan was the one who chaired the keynote session where I gave a talk. What you'll see today is a very abbreviated version with the same intent, but change, with regards to the progress that we have made so far. So the intent of my conversations that day was how should India make its own space, rather than follow the model that, let's say, West or China is following. Is there something that India can be world class and top? Is there something that India should focus on for better value and wealth creation? And that's what you'll see in a very short presentation that I have today. So it's all about, how do we move? Okay. All right, so today the focus is on LLM, right? Almost, at least for most general purposes, for most common people, it's all about LLM. And Sridhar mentioned, some figure about how much is spent. It is expected that $3 trillion will be spent by 2029, and vast majority of them is behind this large language model technology. However, I am going to quote this very important and very interesting observation by Gartner. Says that by 2027, more than 50% of the generative AI model, are ones that will be centered on solving specific tasks. They will be focused on enterprises and solving enterprise problem. It so happened that nearly 2 years ago, I had the same viewpoint. More and more, I think people recognize that LLMs are useful for something. They are good at something like content and creativity, but they are terrible at solving very specific mission critical high value problems. I'll give you example of that. So the alternative to LLMs that are more situated to meeting mission critical needs, and they are the ones that would solve the real world applications in applications like energy and power, in infrastructure, in manufacturing. That's where much of the productivity is to be gained. Okay, so I will also give one quote. This is very, very important quote for all of us to understand. In an enterprise, for most use cases, if you are brilliant 95% of the time and ridiculous 5% of the time, you are dead in water. And then there is an MIT study that says 95% of the enterprise investment fail to deliver. This is because we are using the current technology, the LLM technology. Getting everything out there online you don't know the quality of the data, you don't know the copyright, you don't know, how much of it is contaminated, computer created. Next year, 90% of all the image content on the web will be computer generated. So there is no new data to really train the models on. And in fact, when we hear about the small model today, many of them are technical solution to creating those small models. In the sense that if whether you use quantization or variety of other techniques, you are essentially, compressing, what is there in the large model. Now, it is good that many of them perform very well, but it doesn't fundamentally change the character of what those models can achieve. I'm going to show what we can do and we should do and what we do to solve that problem. I listed a whole bunch of challenges that large language models have, and these are all things for real. It is agreed by the whole community that hallucination is a feature of the way you are taking the data and creating a vast parameter space, and then you have to answer based on what is available in parameter space. So there's no clear solution to that. So there are other alternatives that are needed. I'm going to talk about that. There are plenty of studies out there that shows the quality of results are simply not acceptable for many applications. So here are broad observations. There are few applications that AI will completely solve, and there are. But there are many more that AI can help humans solve. The second is that the LLM technology is quickly becoming commoditized. The scaling is not improving the results. The real value will be in creating the frontier models to solve specific problem. In India, an example is Kisan AI. It is founded by my former PhD student, Pratik Desai. And there are many such models which are purposefully built to solve the specific problem. That's the class of things that I'm talking about. Furthermore, model is only a part of the solution. You really have to build what we call composite AI system, in which you are going to have agents that will use different models. They are not going to be one single models. There will be LLMs. There will be series of small models that will be used in a workflow or in an agentic workflow to solve the problem. So there is a lot of things to do in AI about building these composite kind of systems. So we have developed a framework we call C3N framework, a foundation to responsible AI, where we talk about custom, compact, composite, agentic system, and that is neurosymbolic system. So one very important thing that I talk about is neurosymbolic. My team has been pioneer in this area. We have 30, 40, 50 papers in this area, and we have built real systems in that, and many real world applications have been built using neurosymbolic AI. So there are three components we talk about for building these mission critical AI systems for enterprises: intelligence, robustness, and trustworthiness. And you can see on the right hand side a whole series of what we call as foundation features that are very necessary for carrying out mission critical applications. And now think about it, although I don't have time to talk about it today, think about how many of these are supported well by LLMs. LLM supports a very simplistic form of reasoning. LLM today are leading teenagers to commit suicide. LLMs are not safe. LLMs don't provide user level explainability, where suppose LLM is used by a clinician, the explanation should be in terms of the way clinician is taught the clinical science, right? So all of these things require a lot of things: alignment with the human value, societal value. For example, if you build an automotive solution, then you have law of automatives. If you build a clinical solution, a doctor has to follow clinical practice guidelines. Then your AI should also follow those clinical practice guidelines. Those guidelines are typically specified in a representation as a representation of knowledge in symbolic form, and hence you combine that with neural network based technologies, which are fantastic at exploiting data with the knowledge that is expressed in symbolic to come up with a powerful solution. And this detailed slide is not something that I'm going to talk too much about, but you can see the use cases that I'm talking about. Smart manufacturing, pharmaceutical drug discovery, financial stock market analysis. Many of these will have regulations. Many of these, so we will have to build the solutions, and I've given, I will be happy to talk about this later on at length on LLMs, agents, hybrid architecture and C3 and how they solve. Okay, and here I'm going to just flash a actual use case, actual system that we have built. It's a bunch of agents, the prediction, forecasting, causality, and question answering, and on real world, factory kind of set work. The small models can be deployed on the edge device to solve the problem, to make sure that the factory process, the manufacturing process doesn't come to the halt, that the replanning happens on the fly, and so on and so forth. So several of the real world applications have been built using this model. And now I'm going to end with this just one slide. I'm here for a very exciting mission. From that fateful day that I met Modi ji and had a great opportunity to meet with all the folks at the Chief Secretary's Conference, I had the opportunity to then refine an initiative, and that we are about to launch this initiative quite likely on the 1st of January, where the focus is on creating world-class talent. So I have graduated 38 PhD students, and another 8 will graduate soon, and they have gone on to do fantastic work. They are world-class scientists, entrepreneurs, and academics. Now what happens today is that people go from, after bachelor's, we have fantastic institutions like IIT, but Arvind Srinivas went from IIT, did Berkeley PhD, was at OpenAI, Google, and such, and then he did Perplexity. I also went from here after bachelor's. The maturity that we get after our bachelor, level of education, there is a fantastic ecosystem elsewhere. We want to build that ecosystem here, and that is a great. So creating the innovators who will build products in India with high IP content is the purpose of this thing. Prime Minister said, yesterday, from prototype to product. So we are going to have world-class researchers, H-index varying from 65 to 124. Many of them are coming back with us, and we'll have high degree of reverse brain drain, and very thriving ecosystem that goes from research, innovation, IP creation, entrepreneurs in residence, to creation of the products, and extensive collaboration with the industry. With that, I was there.
Thank you, sir. We now move to the highlight of today's session, the panel discussion on social impact of AI. This panel brings together thought leaders from government, academia, and industry to discuss how AI can be developed and deployed sustainably and equitably, ensuring its benefit reach all sections of society. Our moderator for the discussion is Shri Shashi Shekhar Vempati, co-founder, Deep Tech for Bharat Foundation and former CEO, Prasar Bharati. Sir, may I invite you to on the stage, please? We now invite the panelists for today's session on the stage. Shri Abhishek Singh ji, he is a senior civil servant and technology leader currently serving as Director General NIC, Additional Secretary at Ministry of Electronics and IT, and CEO India AI. Sir, may I invite you on the stage, please? Dr. Harik Mayank Win is the Chief Technology Officer at Tata Consultancy Services, where he leads the company's global research, innovation, and technology strategy. Sir, may I invite you on the stage, please? Professor Balaram Ravindran, he heads the Department of Data Science and Artificial Intelligence at IIT Madras and serves as the Mindtree Faculty Fellow. He is the founding head of the Robert Bosch Center for Data Science and AI, one of India's premier AI research center. Sir, may I invite you on the stage, please? Dr. Rimjim Agarwal he is the co-founder and CTO of BrainSight AI, a pioneering neurotech company using AI for brain mapping and mental health diagnostic. Ma'am, may I invite you on the stage, please? Ms. Debjani Ghosh is a visionary business leader and currently a policy advocate with over 3 decades of experience in the technology sector. Currently serving as distinguished fellow at Niti Aayog, she is the former president of NASSCOM, where she played a transformative role in driving India's IT and innovation agenda. Ma'am, may I invite you on the stage, please? Professor P. Venkat Rangan, Vice Chancellor, Amrita Vishwa Vidyapitham, Coimbatore. He is the VC of Amrita University and a distinguished computer scientist with extensive academic and administrative experience. Sir, may I invite you on the stage, please? May I now invite Shri Vempati to lead the discussion, please?
Good evening. I think it was a wonderful session for the last few hours. I think we have the impossible task, this panel, of standing between the audience and dinner. But hopefully, we'll make it interesting and engaging. How do you, assess the social impact of a technology like AI, which is so fast moving, where the goalposts are changing almost every week? And then that's the challenge for policymakers, Abhishek, Debjani ji. I also, played a role in some of policy making. So how do we deal with, a technology like this, especially when you have questions of inclusivity, sustainability? How do you handle, ensure cultures are preserved, diversity is preserved? So I'll start with you, Abhishek. If you could, set the context for how is the government thinking about policy from a social impact standpoint, from a technology like AI, with all that is happening?
See, if you look at, and it was, in a way, it came out in some of the presentations that were made, is that the role of this technology that we are looking at, especially in a country like India, is the impact that it can make for empowering people, how it can benefit healthcare, how it can benefit services of farmers, how it can help transform education, enable access to people who are not able to access public services. In fact, look at the project like Bhashini. What it has done is that it has ensured that people who are not able to access services which are available only in English or some of the services can be accessed in multiple languages, and more important, through voice. So what it does is that it enables empowering a large segment of people, ensures that the digital public infrastructure that is being built gets exponentially amplified by the power of AI. So that's the role that we are looking at. Just like DPIs have ensured that people have access to financial services, health services, educational services, agriculture services, with AI, their reach goes multifold, and ultimately, if 1 billion people start using such technologies, we'll greatly be benefited in all segments, including our productivity, efficiency, and access to services.
Let me take this forward from the government to the enterprise perspective. Dr. Harik, you are with Tata Consulting. IT services is kind of, especially the Indian IT services sector, is in the crosshairs of AI. A lot of anxieties around jobs, what impact it has on the future of your business. How are you thinking not just about your enterprise but also your customer enterprises? What are the top of mind priorities from the social impact of AI to jobs within your business, and then of course the enterprises that you serve?
So first of all, great to be here. So let me actually start with just one observation, and then I will come to this question. I think we are sort of rapidly embarking on an era of what I would call as hybrid workforce. A hybrid workforce is one where people and machines will work shoulder to shoulder, with each assisting and augmenting the other. So people will continuously assist and augment machines and make machines more intelligent, and machines will continuously assist and augment people to make people more intelligent and more capable, if you will. And this virtuous cycle that is getting created is likely to almost double the capacity of people to generate value every 12 to 18 months. Now, just think about what I just said, right? I mean, we are used to 5 to 7% year-on-year improvement in productivity in terms of almost any domain of work. If it is 10x larger, then the work economics as we know it will get completely disrupted for every domain of work. It is not just software engineering, it's virtually any domain of knowledge work you can imagine will actually get disrupted, right? And by the way, this is not just once, but potentially continuously over the foreseeable future, which means I keep saying that only the dynamic will survive. And the dynamic concept essentially is to say that people, organizations and individuals, that will learn the art of inventing and adopting what I would call as work next practices, not best practices. And that's actually where the name of the game is. So going back to your question about impact on any domain of work, I think the role of people as a result of this hybrid workforce, the role of people is fundamentally changing from doers of work to almost trainers and interrogators of machines, reviewer of work done by machines, and owners of critical thinking and creativity, which means every role is going to get redefined. And as machines become more and more intelligent, the roles will keep shifting. And that's perhaps the biggest challenge that as an organization or as a country we will face, because we have to figure out how to continuously adapt not just the technology, but also the organization and people along with it. And that's probably the biggest challenge.
Professor Ravi, you you're working on co-intelligence recently, responsible AI. Dr. Wembo spoke about, we need to find a different pathway, right? So in your mind, based on the research that you're doing on your radar, what are some possible pathways for low resource sustainable models that could be relevant for the global south, countries like India and similar nations?
Sure. So, so when we talk about low resources, right? So it looks like we are beginning to add a net more resource in which India is already low. I mean, we talked about language resources being low, compute resources being low, talent being low. Now we have to add power generation being low as well as the fourth resource in which we have to tackle. And I think we need to really think about model fit to the problems, as opposed to saying that LLMs are becoming so powerful that they're going to solve all our problems. Right? So I think we have to step back and think about, hey, look, do we really need somebody who can solve a math Olympiad problem, right, to help me write my code? Right? So likewise, if I'm going to have a Gen AI model or whatever, an AI model that's going to help an ASHA worker, to take healthcare to the rural villages, right? How capable should that AI model be? It is not like for every job we're going to hire a human who is an Olympiad winner. So why would we need do that for AI as well, right? I think we have to really take a step back. Start thinking about what is the model fit to the problem that we are solving. And that can happen only when we start looking at AI as a truly interdisciplinary discipline, right? As opposed to having, large IT enterprises or the top-notch computer science department spewing out the next boundary pushing model and then letting the others to figure out how they would use it to solve their problem. Instead of that, people have to really work together and, like you said, co-create the true intelligent value, right? The delivery that needs to happen. I think, and India is, we are at a great point where we can actually do that. So we have just about enough resources to start doing that. We might not have resources right now to get our next DeepSeek moment, but we certainly have, the platform, the ability, the will and the support of the government and other organizations to start looking at how we would use AI to solve problems for the country. And I think we should take advantage of that and push ahead. And at IIT Madras, we have been doing this for several years now, where AI is treated like an interdisciplinary subject, not as a computer science computing discipline alone. I think we should encourage that and push that boundary further.
So, Dr. Rimchim, you're from a healthcare AI startup. I'm sure you're dealing with all the challenges of, building a small organization in such a fast-moving, fast-changing technology landscape. What are some of the challenges that you are facing, especially from a healthcare standpoint, to make sure that the technology that you're building is inclusive, scalable, and most importantly, affordable? The example that Professor Ravi gave, right, of the ASHA workers, for example.
First of all, thank you for having me here. And the three important points that you have mentioned, affordability, scalability, and inclusivity. It's largely very loaded statement. So I'll just give a 15 seconds of introduction of what we do. We are doing brain mapping, and right now in around 50 hospitals in India, it is used commercially for advanced care of brain. Now, it is used in surgery. So we need to build a product which is surgical grade, life-saving, and also quality of life. But when it comes to advanced care in India, in general, we start importing things. So that is the part where the affordability goes out. We are not creating things within India when it comes to advanced care. Like Dr. Geeta was mentioning, she's in the screening part. We need more company which will take things end to end, from the screening to the end to the advanced care and quality of life. That is when the affordability will increase. We have immense data to create the models, to make sure that we have good amount of testing done on each and every device. We have good pharma companies to back these things up. So we do have resources. However, we need more we also have intellect. We need more focus on the advanced care, is what my belief is. In terms of scalability, I do believe that people also trust the technology which is coming back to India. So something which has CDSCO license versus something which has FDA license. That will have a huge impact in terms of trust. And people would like to depend on the FDA licensed device rather than with the CDSCO licensed device. And even if it is AI, it requires CDSCO license, FDA license, so on and so forth. So software as a medical device right now requires the amount of credibility which is coming with FDA, etc. And in terms of inclusivity, if you will see, we require inclusivity of all kinds. Number one, at the gender level in the data set, because till now a lot of medical data set was majorly male dominant. All the imaging used to happen, a lot of imaging used to happen. This is just like some 10 years of changes that we are seeing where the data sets are well balanced. But till before like 7 to 10 years back, the data set itself was very male dominant. Even if you see the car seat belt is not optimized for women. So similarly for medical also, the data sets are not optimized for women. And those changes need to be there, and we need to get the data set which is well balanced considering all the genders in the society. And also the demographic that we are looking into, plus the gap between the poor and rich, the data set coming from high education, low education, those also have impact when it comes to advanced care, like brain size itself changes with these changes. So.
Great. So Devyanaji, I would first want to go to Dr. Venkatraman and then get you to comment on all the perspectives that we heard from a policy perspective. So Dr. Venkatraman, how are you keeping pace with all the advancements with AI in a university environment? How is the university coping with it?
Sure. I have just a couple of slides.
Do we have?
Yeah. So just a couple of slides. What we have is a hi-fi model of AI, an ecosystem for universities with health and medicine as a case study. I'll just take 2 minutes of your time. Human health is probably the greatest unsolved problem in every part of the world, developed or not. Many grand challenges keep us awake past midnight. Almost all disciplines are joining forces, but AI seems to be the captain. How are we preparing our next generation for this? First, the I-5, first we started a BTech program in AI, co-located with the medical school. So as a result, our software and AI students work in adjacent floors, and we call this re-engineering health. A contradiction in terms. We have both engineering and health. Next, we have set up an innovation hub that provides a pool of AI programmers to rapidly prototype data-driven studies by the physician scientists, because these physicians have very little time. So the third is global collaborations, because for us it's a must for the data to be diverse and robust validation. We need the global data. For the outcomes to reach the population of our industry is very important. And fifth and the foremost is the impact on India, which translates to the 3 A's: accessibility, availability, and affordability. So I just point out that AI is heralding some paradigm reversals. The Wear, Watch and Wellness, W3, what is happening is the home becomes the holistic hospital. So, and in medicine, experience and evidence is captured and quantified as the patient data, which is the EMR, and the physicians are learning from patients. So more patients, so patient becomes the physician's preceptor. Okay, last slide. However, there's something missing. Compassion is a missing factor when you have only AI. So the geekiest way to define that is computation is solving the problem right, compassion is solving the right problem. And this I learned from my most distinguished student, Professor Harry Quinn.
Excellent. So if I can now go to Debjani ji, I think very interesting framing, solving the right problem, and as a policy maker at the frontier, looking at frontier technologies, can you zoom out and give your perspective on all that you've heard on, how are you, factoring the social impact, the social sectors when you look at technology policy?
So I'm going to wrap this up by going back to the beginning and what Mr. Krishnan said, that in February, India is going to host the largest AI summit, the Global AI Summit, and we have very consciously decided that the focus of India's summit is going to be impact. Right. And I think that's such an important point. And why have we chosen him? I'm not going to get into that here. But while the world is today crying about where's the ROI, is AI a bubble or not? I mean, all these conversations are going on, right? For India to come out and say, we are going to focus on impact, and we are going to show the way to impact is very important. And of course, when India talks AI, we always talk about inclusive. So the work at NITI that we are doing, and again with MITI, is to figure out how do we unlock the pathways to this impact across sectors, right? And one of the key sectors is social sector. How do you unlock the pathway to impact? So for example, a critical problem in social sector is 90% of India's workforce is informal. 490 million people out of the 500 and whatever odd total workforce we have is an informal workforce. Accounts for nearly half of the GDP, right? They're invisible in the system today. If India has to grow to Viksit Bharat, we're looking at a per capita GDP of 18,000. This sector has to grow to around a 14,000 per capita GDP. Today they're at 1,500 roughly. It's too big a jump. But this is where technology has to come in. And this is where you can unlock impact, right? So when you're thinking about impact, the technology artifacts become invisible. It's no more about LLMs, or it's about the problems and what's the best way to solve for these problems, right? Again, going back to the informal sector of India, one of the biggest problems there is lack of identity. You are not known for your craft. You don't have an identity that you can talk about saying this is how good or bad I am. Now again, you start thinking about how do you use technology to solve for that? How do you democratize intelligence completely? And that I think is what AI is supposed to do. It's about democratization of knowledge and intelligence. So you start thinking about these things. And I think the two things that becomes very important, we have the talent. I absolutely believe we have the talent. Well, more than anything else, we have human ingenuity. We know how to deal with restricted, limited situations, and that makes us very creative. But the two things that it comes back to is data and then R&D. And then, how do we get these two right to solve for this? But figuring out how to use AI to drive real impact We have to stop thinking about artifacts. We have to stop thinking about LLMs, etc., etc. Those are, they will happen. They're plain and simple artifacts, right? But how does the democratization of knowledge help us solve for these problems that everyone here has talked about, and what do we need to do to enable that democratization, which I think is what the India AI mission is doing today.
I think that will take me to Abhishek to wrap up the entire discussion. How do you unlock pathways for impact, and how do you democratize? How are you thinking about regulations from an India AI standpoint?
So like, of course, two different things, and I'm sure it will require a lot of time to cover that, but in short, to unlock pathways, what we've been doing as part of the India AI mission is to address all the gaps that exist in our story. As Debjani mentioned and others mentioned, our biggest advantage is the talent that we have, the human capital that we have. But in order to build models or develop applications, the field of AI, you need a lot more. You need compute, which is very expensive, and number two, you need investments for ensuring that compute is made available, and you need data sets that are AI usable. So what the AI mission, we are trying to address all of it by having the compute pillar under which we have got low-cost compute available, accessible to those who need it, the datasets platform that building AI Kosh, the foundation model support, because foundation model, even though there is always an option of using the open source models, but it's also essential that a country like India with the volume of usage that we have potentially and the talent that we have, we need to have Indian foundation models, then providing support for application development, providing support for startup financing, providing sustained support for skilling, and building tools for safe and trustworthy AI. So the 7-pillar strategy of India AI mission is designed to build pathways for us to be able to catch up with the best in the world, whether it's US or China, and ensure that we are able to build applications which will not only be of use within India, but it can become an example globally. And as far as safe and trustworthy AI, our regulatory framework, will have some announcements tomorrow, the India's AI governance guidelines, which have been developed by a committee under the principal scientific advisor to the government of India, and that lays down the roadmap for ensuring that AI applications and models built in India are not only innovative, but also conform to the ethical and the safe and trusted strategy that we have for that. Yeah.
Great. I think so. We are almost running out of time. So quick closing thoughts, 30 seconds each, starting with you, Dr. Harik. All that you heard, what do you see is the way forward?
So I just want to build on what you just said. I would suggest that we should look at, I think there was one point that was brought up earlier also today, that I think today if you look at almost any domain of knowledge work, doctors, lawyers, software engineers, you name it, anything, right? There is a huge gap between average and elite. Almost elite is almost 100x better than average, right? While we are actually, I'm going back to your pathways point, while there is a lot of emphasis to build AI infrastructure, as well as a lot of the use cases people talk about are actually to improve productivity. It's actually offering information and automation at the fingertips of people. A great opportunity is to actually use AI to actually make people dramatically better. Because if you think about any domain of knowledge work, it's actually a combination of decisions and actions. The quality of outcomes depend on decisions. Productivity depends on actions. Everybody's talking about actually focusing on actions. We should probably focus on decisions. And if you can make an average doctor in a village as good as the best doctor in Delhi, I think we will transform the country.
Great. Professor Ravi, your closing thoughts.
Yeah. So one of the things, again, building on the theme that we're talking about, right? So AI is not just affecting a few industries or a few disciplines. In fact, it's going to affect everything, including the way our society operates. It's not even, in fact, somebody was asking me this question, hey, can I trust a phone call that comes from my mother anymore? Right? So, we're going to go to a point where even that is going to become a challenge as we go forward. And I think a lot of work needs to be done. Just one other point that I wanted to make, right? So in India, right, so we have a very uneven availability of everything. Right? So we talk about, we talked about healthcare not being available, but there are at least 100,000 schools in India where there is just one teacher teaching for all standards in the schools. all subjects, all standards in the school. So a lot of work that needs to be done. In fact, to create impact, I think a lot more that we can do with the existing resources, and that's what we should be building towards.
Dr. Rimjim, very quick closing
Yes.
thoughts.
So let's say right now what the data says that 90 to 95% of use cases in Gen AI is also failing. It could be a hype, but the reality will come only after the hype. So I think we need a more focused understanding of what real problems are instead of running behind the methods. Gen AI, all AI is just a method. Instead of running behind the method, we should be focusing more on the problem. Methods will come by itself slowly.
Great. So on that note, I think our panel will have to wrap up because we have Secretary Mighty who has to felicitate everyone. So thank you. I think the conversation will continue till the AI Impact Summit.
Thank you all to our esteemed panelists and our moderator for a truly engaging and insightful conversation on the social dimension of AI. May I now invite our session chair, Shri S. Krishnan, Secretary Mighty, to felicitate our speakers for their valuable contributions. Dr. Sridhar Vembu, Dr. Geeta Manjunath, Dr. Sriram Raghavan, Professor Amit Sheth,
My turn to get back at you. Not giving him the same thing again.
I would like to invite Dr. Sriram Raghavan also on the stage, please. Oh, he has gone. Amit sir. Okay, no? He left here. Sir, वो तो फोन Can I request the committee members also to come on stage for a group photograph? So as we come to the close of the thought-provoking session, we are deeply honored to invite our session chair, Shri S. Krishnan, Secretary Mighty, to deliver the concluding address. Please.
Now, I think we've heard from all the experts, and it would be really unfair for me to try and sum up this entire session, given the breadth of what was shared with you. I only thank all the keynote speakers and the panelists who joined us here today, Dr. Sridhar Vembu, Dr. Geeta Manjunath, Dr. Sriram Raghavan, Professor Amit Sheth, and of course, the members of the panel whom you just heard. Each one of them offered a wonderful insight into various dimensions of AI, and also the further possibilities that exist, how far this can actually go, that the last word has not been said on this, and the profound impact that it can have on all of us. So that is the context which is very critical for the upcoming AI summit as well. There are a number of pre-events being held. There's a lot of work which is going into it, and we look forward to meeting all of you again. On this occasion, I would just like to, because we have a gathering of so many innovators, so many young researchers and scientists here, I just want to actually request all of you and call upon all of you to continue to work in this space, continue to build solutions that solve real problems for real people. The work that you do today will shape the way that the country itself progresses tomorrow. And we have to keep pushing the boundaries of what's possible and also figuring out what is actually necessary in the present circumstances. Now, industry players are also there. They need to really participate with us in this national mission. They have to add their might, both in terms of expertise and mentorship and resources. And of course, people like me, policymakers and administrators, we really want to build as many partnerships as possible, create that enabling ecosystem where all of you can partner with us. Truly, if there is one mission in the government which fully involves stakeholders and is run on the basis of what stakeholders contribute, it is the India AI mission, because that is one place where it is led by private enterprise, it is led by what the innovators require, it is led by what industry needs, it's led by what academia brings to us. And ultimately, all technology, everything that we do as a government is ultimately about the people, because it's about jobs, it's about their welfare, it's about what we can deliver for them. And to paraphrase that song, every breath you take, if I may say, every algorithm that we write, every model that we train, every application that we deploy must ask the fundamental question, how does this improve the life of a common citizen in India? And that is the basis, and that is what we take away from today's session. I once again thank all the keynote speakers and panelists for their very valuable contributions. Thank you all.
Thank you, sir, for your insightful and forward-looking closing remarks, perfectly summing up the essence of today's deliberation. Now I thank you all and have a wonderful evening ahead. All the guests, you may not, there is a cultural program at 6:30 p.m. So you may all please join us here. The cultural evening is by Mr. Ricky Cage. He is the Grammy Award winner. Thank you all.